Before we practice, let's cover one last vocabulary word, and that is the identity matrix. The identity matrix is basically the reduced row echelon matrix from last lesson. So we can have the identity matrix will always be a square matrix, 2 by 2, 3 by 3, 4 by 4, 5 by 5, like a reduced row echelon form. And it will always tell you what size it should be. So the I2 is the 2 by 2 identity matrix, 2 by 2, and then you'll notice from there it's just reduced row echelon form. 1 on the diagonals, zeros everywhere else. The I3 is the 3 by 3 identity matrix, 1's on the diagonals, zeros everywhere else. I4 is the 4 by 4 identity matrix, 1's on the diagonals, zeros everywhere else, and so on and so forth. So if you see any of these in your homework or on your test, just know that they're a square matrix that looks like reduced row echelon form. Now, with that in mind, I have a bunch of practice problems for you. In A and B, we have some addition. In C and D, we have some multiplication. And E and F, we also have some multiplication. So here's what I would like you to do is pause the video, try out all 6 of these problems. Remember that for addition and subtraction, make sure they're the same dimensions or they won't work. And for multiplication, we check those inside dimensions and make sure that they're the same. If they're not the same dimensions, we can just immediately write D and E and move on. So I'm going to have you pause the video at this point, try all 6 of these problems, and then come back to check your work. Let's check your work. So for A plus D, they're both 2 by 2s, which means I can add them together. You just add the corresponding spots. So this one to this one, this one to this one, this one to this one, and this one to this one. And you get your final answer. For A plus B, they are not the same dimensions, so that one's a D and E. B times C, we check the inner dimensions first. This is a 2 by 3. This is a 3 by 2. The inner dimensions are the same, 3 and 3. So my answer is going to be a 2 by 2. So those are the spaces that I made here. And then I multiplied them out in that right pattern to get this as my final answer, 2 by 2. For any of these, if that is not the answer you got, feel free to pause the video, go back and look at my work more detailed to figure out where you went wrong so you know how to fix it. Then I have C times B. C is a 3 by 2, B is a 2 by 3. So once again, the inner ones do match. My answer is going to be a 3 by 3, which I made here. I did my pattern in all the right direction, all the right colors to get that as my final answer. Next, I did B times D. B is a 2 by 3, D is a 2 by 2. The inner numbers do not match, so I can write D and E right away. And D times B, so D is a 2 by 2, B is a 2 by 3. The inner numbers do match, and my final answer is going to be a 2 by 3. So I made a 2 by 3 here, filled it in with the patterns, solved it to get that as my final answer. Now, E and F do portray a really good point in that multiplication with matrices is not commutative. We're used to being able to flip the multiplication and it's the same answer, like 3 times 4 is the same thing as 4 times 3. With matrices, that is not true. B times D is not the same answer as D times B. And we can even see that here. B times C is a very different answer than C times B. So matrix multiplication is not commutative. You can't flip it and get the same answer. Now, we're going to do one last example for today. This one is going to string together everything we've learned so far. So let's write out what we've got. First, we have C squared, which we know is C times C. So I'm going to write this out. I have my C matrix times my C matrix. Let's check and make sure that's possible first. This is a 2 by 2 and a 2 by 2. Inner numbers do match, so that my final answer will also be a 2 by 2. That does work. Then we have minus 5 times C. So this is our scalar multiplication. We just times everything in C by 5. Plus 10. There's that I2. Remember, that's the 2 by 2 identity matrix. So it's 2 by 2 reduced row echelon form. There's our 2 by 2 identity matrix. And that scalar multiplication, we just times everything in there by 10. So I'm going to have you pause the video once again. Remember to take care of all the multiplying first, order of operations, then take care of the adding and subtracting. So multiply these together first, multiply the 5 into here, multiply the 10 into there, then you're going to take this answer minus this answer plus this answer and see what you get. So pause the video, try all that out on your own, and then come back to check your work and see how you did. Let's check your work. So first I did C squared. It's a 2 by 2 times a 2 by 2, so it's possible. I did our pattern, and this is the final answer I got for C squared. Next, I had -5 times C. So I just multiplied everything in C by 5, and then I carried it down here, so I get subtract. There's my 5C. And then I get add 10I2, so there's my identity matrix, multiplied everything in the identity matrix by 10, carried it down, so I get add that thing. Now I need to make sure they're all the same dimensions, 2 by 2, 2 by 2, 2 by 2, so I can add and subtract these, we're good, and then I just do the spots. So -5 minus 5 plus 10, that's my first spot. -10 minus -10 plus 0, that's my second spot, and so on and so forth to get a final answer of all zeros. So that is our last example of our matrix operations. We are officially done with lesson 6.4, and you can now get started on your homework.